Hi there. Let's take a look at some more examples using the Totient function or phi function. Okay. So this time we're going to look at, we're going to move out of prime mods. We're looking at, now it is a 5 squared, so there's still a single prime that we're looking at. But we're not looking explicitly at a prime mod this time around. So the question is, what is 12 raised to the power of phi of 25 in mod 25? And then we'll do the same thing for 15. And we'll see that there's some different things going on here. And we'll talk about that as they come up. So one thing, again, remember we're living in mod 25 here. So that's kind of important to remember. One of the things to think about, so we're going to talk about what our phi for 25 is. One thing that, if you remember back to when we calculated using modular arithmetic, and we could see how raising a number in a prime modulus to one less than the prime gave us the value of 1. Well, if you think about it, the phi function of a prime number is going to be that prime number minus 1. So for instance, if I had p was 7, then phi of 7, well, every number 1 through 6 is relatively prime to 7. So therefore, the phi of 7 is going to be 7 minus 1, which is 6. So it's kind of, in that case, we would notice that the phi of something would give us 1 less than the modulus. So if instead of mod 25, we were looking at a mod of a prime number, then that exponent would be 1 less than the prime number. We would know that that's 1. Now, does that work in this case? Well, let's find out. So let's first of all calculate what is phi of 25. So remember, we're looking at, it's really 5 squared. So I could go ahead and start listing these out. But in the previous video, we found a rule for that. We found out that it was going to be 5 squared minus 5 squared. Now, instead of dividing by 5, by 3, it's dividing by 5. So it's 5 squared minus 5 to the first, which is just 20. So q of 25 is 20. I'm sorry, I keep saying q. Phi of 25 is 20. Okay, so what we really are asking now is 12 to the phi of 25 is 12 to the 20th. And what is that in mod 25? So do we really want to multiply that out? That's going to take a little bit of time if I find out what 12 to the 20th. One thing you don't want to do is you don't want to pull out your graphing calculator. You don't want to use your calculator on your phone, or even things like Desmos, because the problem is that you're starting to, like if I take 12 to the 20th and I plug it in there, the problem is that number is going to get big enough that the calculator is going to start rounding those integers. And you will not get, it will go wrong. So 12 to the 20 is not too big, so that we might be okay. But if we start to get to any numbers bigger than that, forget it. It's not going to happen. So yeah, we could go to Wolfram Alpha or something like that, but there are easier ways to do this, or at least more kind of clever ways. And so that's what I want to look at. So one way to do that is to actually just kind of, let's make a table. So my k value, what I'm raising it to, and I want to do 12 to the k. Okay, so k equals 1. That's easy. I get 12. Piece of cake. What if k is 2? Well, 2, so 12 squared is 144. But we know that, what would that be? So 125 is the first multiple, so 19. So that's going to be 19. And then I'm going to, so here's an interesting thing. I don't need to figure out what 3 is. Okay, it's not worth it. So I'm going to skip over to 4 because 12 squared is 12 to the 4th. So if I just take 19 and square it, well, what do I get? I get 361, which is pretty close to 350, which is 11. So I know that 12 to the 4th is 11. Now I'm going to basically do this kind of repeated squaring thing to get myself to 20. Now what would be really helpful is like 12 to the 4th squared is 8, and then 16. It'd be better if I could get to 12 to the 5th. Well, since I know 12 to the 4th, and 12 to the 5th is just 12 to the 4th times 12, I can basically take 11 times 12, which is 132. And then again, subtracting 125, I'm going to get 7. Okay? And now I'm basically going to skip over 6, 7, 8, and 9. I don't need those. And I can get right to 10 because 12 to the 5th squared is just 12 to the 10th. So what's 7 squared? 7 squared is 49. So that ends up being 49. But mod 25, that's 24. But here's the cool thing. 24 is 1 less than 25, which means in our special mod world, this is really just -1. And so now I'm going to skip over everything up to 20 because 12 to the 10th squared is 12 to the 20th, and -1 squared is 1. So notice we didn't have to calculate all that. I did that pretty quickly. I wasn't trying, like, there was a couple of multiplications that I might have had to take a minute to figure out, but there was not a lot of extra work we had to do there. And we certainly didn't need to know what the integer value of 12 to the 20th was before we did any of that. Okay, so keep that in mind. So here's an interesting thing is that even though mod 25 is not a prime number, there is an interesting relationship going on here that we raised 12 to the phi of 25, and it turns out we got 1, just like we were doing when little Fermat was working with our prime mods. So let's see if that works the same way for 15 phi 25. So I'm going to do, we'll make this, actually, I don't have to move that up too much. Let's do the same thing. So k, and I got 15k, and I'm going to raise it to the first power. Piece of cake, no problem. Let's square that. 15 squared would be 225. Huh, well, 225. Which is a multiple of 5. Or, I'm sorry, it's a multiple of 25, which means it's 0. Which makes sense because 5 is a factor of 15. And so if I multiply 15 times 15, I'm essentially multiplying a 5 times a 5 and getting a 25. Well, that makes the rest of it pretty simple because 12 times 0 is 0. 12 times 0 is 0. So it doesn't matter what happens between 3 and 19. When I get to 20, all of these things are zeros in here. And so 15 to the 20th is 0 in mod 25. So the question is, why? Well, I think by now, hopefully you can kind of see what's the difference between these two problems up here. In the case of the first one, the GCD of 12 and 25 was 1. They're relatively prime. But the GCD of the second problem, 15 and 25, was 5. So in one case, at least a version of what we saw with little Fermat works, but it's not guaranteed to work, particularly if the base of our exponent is not relatively prime with modulus. Okay? And that makes sense because when you think about it, what we're really looking at with the Q functions is you're looking at all of the things that have an inverse, can be undone. They're all the values in the system that can be canceled. That's what the phi function is giving us. Okay, and so in this case with 15, 15 is not in that list. 15 is not part of the congruence classes that are relatively prime with 25, and that causes a problem in this case. Okay, hope that makes sense.